locked in, as you would be if you picked something like Google and wrote your application using Google Apps. Then you'd be locked into them as a vendor. Here we have multiple choices. There's different private cloud distributions, people who have built something on top of Cloud Foundry. There's various companies, AppCloud, other companies are offering Cloud Foundry as a service, so you can sign up with these. Different infrastructures, you can put Cloud Foundry into Amazon, into Rackspace, other types of places. CloudFoundry.com is an example where there's an infrastructure provided with a number of much hardware and then virtual machines in each of them, and then various services, runtimes, and frameworks that are out there provided. Microcloud, you can download your own cloud, run it on your laptop, and again, has a variety of services, runtimes, and frameworks. Generally, you need to have something that can run a virtual machine, and so I have Fusion running on my Macintosh. Others who have Parallels if you have a Macintosh, but you can also get VMware you get virtualization that runs for Windows and Linux. CloudFoundry.org is an open source place where people are adding new features and adding support for new frameworks and runtimes. And if you want to, you can download the code, set up your environment, and just start running it. You can enhance it. It's a GitHub clone source, and you're up and running. A logical view of how Cloud Foundry works, if you're outside, this would be Cloud Foundry inside the lower box. Browsers, so a web browser, a client on your customer's laptops, or your laptop, or your outside your smartphone or something like that is inside Cloud Foundry. The routers direct the browsers to the right location. You can also use tools for the developer to connect to your cloud. So if you're on Cloud Foundry, you have a web browser. Web applications are communicated with using a request response. So when you type in an address into the address bar in your web browser, it sends a request. That request goes to load balancer routing inside Cloud Foundry. That then sends the request onto your application instance. Your application instance is listening and running. It might communicate with a database for services, and then sends a response to the load balancer, and the response goes back to the browser. Scaling. One of the issues that you get if you're dealing with a web application is, what if my business becomes more successful and I need to add more instances, runtimes to my system? Well, VMware or Cloud Foundry supports scaling, so you can just have multiple instances of your application. And the router and load balancer handles this, so that the requests all continue coming to the same place, but then get routed to different instances of your application to be handled. How do we update applications? Well, here we start with the previous version. You briefly stop the instance, and then update your code, and then start it up again. And so you can just say, stop, update, and then restart. And you're up and running with a new version of your application. VMC update my app will take care of that. So, we're going to start by looking at the trivial demo application application that's provided with Cloud Foundry. And that gives us an idea of the architecture and helps us then understand how Smalltalk might fit into this. So imagine we had a new directory, create a single executable, a Ruby file that just says it's going to be a Sinatra app. We're going to, when they ask for these routes, we're going to put out these responses. So we can try that locally, we can push it out to the cloud, and then we can go view it. So let's take a look.
Starts up, it's on port 4567. So I could go to a web browser and say localhost 4567. And so here's greetings to the small talkers, and if we say /env, then we get some other information. This is running a Ruby application on my Mac, nothing to do with Cloud Foundry. But instead, then if we say, well, we're done with that, I'm going to say BMC info, which is tell me what I've got happening in my environment. I'm connected to smalltalk.com, and I can interact with that there. So I'm going to say BMC push. And so it says, would you like to deploy from the current directory? I say yes. I'm going to name it ruby-env, and then I'm going to, it says this looks like a Sinatra application, and so we'll go ahead and push it up to our server. And this is a server that we have running in the United States, and it's creating an application for us. And it's updating it, and it's now preparing it to be out there, starting it. And so now if I go to my browser and say API smalltalk.com, this is my, this is the instance of Cloud that we have running. I'm going to then change the address to say Ruby environment. And so now it is running a web application on a server in the cloud, and it's out there. We can ask for some environment. And so it gives us some information about the environment variables that are running for this Ruby application. So we can view the application. We can then increase the number of instances running. So right now, BMC instances of it says there's one instance running, and it's at index 0. If I say BMC instances Ruby environment +1. What the cloud is going to do is it's going to increase the number of instances to 3. And so now we've got 4 of them running. And if we go back to our browser and say, you know, what information do we have here, it might change periodically. So this time we're listening on port 6000. 30, 6,866, 30. So it rotates through various ones. It might reuse one that's available. So we've got different things running. So we've got a few applications running. We can scale up. So when we're done, I'll go back and say PNC, delete, Now, again, the push process here was it created an application, it uploaded the application, it made sure there was resources for it, and then it started. So I have a laptop with my application, and I am pushing the entire application out to the cloud, and it's running. So I have my client, there's a web browser, it's talking to the Cloud Foundry service, going through a router to look at the application instances, and all running there in that environment. Now, we'd like, of course, to add Smalltalk to this. Ruby is nice as far as it goes, but what if we could bring Smalltalk into this environment? And maybe even Gemstone. So, how would that work? Well, the traditional environment has Ruby with an interpreter that works with text files. Application code doesn't include, which loads other things. The frameworks, Rails, Sinatra, these things, the application framework can be preloaded to the server. Java, there's a runtime that works with jar files. Application code includes external libraries. The frameworks can be preloaded on the server. Okay? I hope you're sensing a pattern here. There's some differences in Smalltalk. We are used to working with a monolithic image that has the full application framework and everything built into it. But we might be used to that with Smalltalk, but that's not the way we have to do things. We can actually use packages or files. So we could push a small snippet of code and ship just the code and send that to the server and have it get loaded. The staging is launching Smalltalk, loading the code, saves the image. That happens on the server side. Then we can start the save image, figure out a port, start the server, and then do that. So I'm going to take a Pharaoh application, for example, and I chose Ada for this experiment, where we put Ada in app directory. It has various things. We have a start command, some Smalltalk. So here's our Smalltalk that says, go into this directory, look for this .st file, and load that file and evaluate the contents. So start running. We have a special file here that does some things for us. It reads the port number from an environment variable. It sets the port number for Ada, and then compiles something that just, we're going to have something a little different to show that we actually have code. We do need to change Cloud Foundry to recognize Smalltalk. So there's a little bit of a change on the client to say, I can recognize Ada as an application. And some things in the server that has scripts that will download and install COG, virtual machine, in the Ada framework. Then staging code to install it, save the image, and then run. So I'm going to go directly to the demo, I think. And let's take a look. So here, I have a directory, local directory, cloud, Ada app, and it has one file in it, aida.st. And that is just something that says, listening to Smalltalks 2012 on port such and such with this. So I'm going to say, VMC push. It's going to say,
you want to deploy from the current directory? I say yes. I'm going to name it Ada, and it's going to use this URL. Is this an Ada application? Yes, it is. Do you want the standing amount of memory? Yes. How many instances do you want? One is fine. And do you need any services with that? No. And we don't need to save it. So it's creating an application, uploading it to the server. It got to the server okay. Now the server is launching a Smalltalk image, loading my code into that image, saving the image, and quitting. Then it sets that image aside as an application bundle that's ready to be used. Then it reads that and starts it. So now I can go to a web browser and say aida.smalltalk.com.org. So here, and you could use this too if you're connected to the internet, you have your laptops there. The URL again is just aida.smalltalk.com for conference.org. Okay? We'll try one other example to do something a little more sophisticated. Here I'm going to have an Ada application that does something a bit more complex. I'm going to actually use a database. So what I've done is I've created a series of MCZ files. So on to go. So here is going to be a series of MCZ files that are all in this directory. If I look at aida.st, what my Smalltalk script does is it installs various files, registers some applications, and that's what my application does. So if I say vmc push from this directory, yes, this is going to be something called balance. And the URL is going to be balance.smalltalk.com. Is this an Ada application? Yes. Memory. How many instances? One. And then it's going to say, would you like any services? I'm going to say yes, because this is going to be a MySQL application, Ada and MySQL. And then it's going to create the application. It's going to take everything in this directory, all the MCZ files, push them up to the server. The server is going to take them, launch a Smalltalk image, run the script, which loads the MCZ files. Once it's all finished, it's going to save the image, quit, bundle it up, and then set it aside to be loaded and run. So it's staged it, and now it's running. So now we can go back to our application and say we're going to go to balance. And balance is going to say, well, we're here. Ada, as it happens, wants us to log in. And so now we're going to go to MySQL balance. And this is an application that's demonstrating using a database. So I can come in here and say 40, adjust, and it goes out to the database and comes back, and now the balance is 40.
I sent you an email.
You did? Yeah, good to see that. Now, if you are using your computers, want to try this out, you can go to smalltalk.com.org, MySQL balance. And if you type in values there, if I refresh this, then the value will change. So I can add 30, and it's now at 70. I can subtract 38, and adjust, and now it's 32, and so on. So here is...
What's the login?
You do not need to log in. If you go to this, rather than just saying balance, say balance / MySQL balance.
Okay.
Okay. And so right now, I'm going to 32. So if I do a refresh, there to be working from my home or from my apartment, but I'm plugged in to work this morning here. So, microcloud would allow you to develop it locally, test it, then you can deploy it to a public cloud. So, key takeaways is platform as a service is a way to just develop your application locally, deploy it with minimal cost. So if you want more information, you can go to these URLs, cloudfoundry.com, cloudfoundry.org, gives you links to the source code. You can download your own microcloud. There's a blog, Twitter account, but you can also contact me or go to my blog, where I've got quite a bit of Cloud Foundry demos and comments. So we started a couple minutes late. Yeah, a couple minutes late. Okay. Any questions? Or let people go on to the next thing. The handheld microphone.
I have a question.
Yes.
Because you showed this application working, was it working with Faro or with Gemstone?
This was a Faro application. Now, I can also do Gemstone now.
I saw that it was an option.
Yes.
And it was a Gemstone. So it's already installed in Cloud Foundry and Gemstone, or do you have to do something special?
There needs to be some special things done, and I have done that. They keep updating Cloud Foundry, and so each time they updated it, actually, when I tried it a couple weeks ago, it was working. Then I did an update on my laptop because I wasn't trying to connect to the network, and everything broke. So Cloud Foundry is very rapid development, but we have to run Gemstone in the cloud.
Cool. Any other question?
Oh, thank you.
Well, in the Foundry, do you have something like Topaz to touch the data in your, I don't know, it's just a gem or?
Yes, so if we were running Gemstone in the cloud, what we would get is a web server. So you would not have the traditional Topaz interaction. One of the characteristics of the Cloud Foundry architecture is that everything comes in from a web browser into port 80. You cannot get into Cloud Foundry except through port 80 and a web server, unless you're coming from a VMC client. So there's essentially two ways in. One is the developer, the other is the application user. And the developer, the only thing you can do is push your application, query when you're running, start them and stop them, change the number of instances. From the browser, you're just coming into some URL, and you've registered that URL so it maps the name to a particular application. So when I'm mapped to Ada, it will send it to one particular application. When I map to Ruby, it will send it to another. If I map to Gemstone, it would send it to a different application. Now, yes, we have Topaz running, for example, on the back end, but the only way into it is through the router that then goes to a different port. So you need to have a web server listening through your Topaz. But then once you have that, you could have a web application that would give you access to just Gemstone Smalltalk code. And so that's actually the longer demo if I have more time.
And what about the size of the objects? Because I've seen that you can increase the number of instances of your application.
Yes.
But what is the size of the object server, and can I
Yes.
increase that?
What is the size of the object server? When you sign up for a cloud, an account account on a cloud server, you would be given some amount of memory. And so one of the questions that it asked us was, do you want 128 megabytes? Do you want 256 megabytes? Do you want 512? And so on. Now, what you would get would depend on what account level you asked for. So I don't think any free service is going to give you 4 gig of RAM and a terabyte of disk. But the default will be small. And so, for example, our AIDA application environment was using a 128 meg of RAM. And then again, you don't really use any local disk because the applications can get started on different machines, and you don't have file system access that's shared. You need to be prepared for them to be used. So that's why we've had the persistent database. So again, you would have an account that would give you a certain amount of size. Now, if we were doing Gemstone, again, you could configure it, and it would be simply a matter of how much disk and RAM you get. So when we went to VMware and said we would like to give a demo of Cloud Foundry at the Argentinian Smalltalk conference, we would like 4 machines, we'd like them to have this much RAM. They said, well, okay, but you can only have this much RAM and this much disk. So, but if you pay for more, you get more. There's no real architectural limit. And of course, with Gemstone, you can have, if you can use gigabytes of RAM and terabytes of disk.
Thank you.